Welcome to The Explainer. Today we are diving deep into some seriously cool engineering. We're going to uncover the magic that lets some of the world's biggest apps promise 100% uptime and actually pull it off.
I mean, you've got to wonder, right? You're smack in the middle of some huge online event, maybe a Black Friday sale, and the service you're on is just flawless. It feels like it's running on magic, but it's not magic. It's just some absolutely brilliant architecture.
So here's our game plan. We're going to look at what that always-on promise really means. Then we'll explore two huge concepts that make it possible: the fortress of data centers and the shared skyscraper. And finally, we'll see how they snap together to create a truly invincible architecture.
So what does it really take to build an app that just refuses to go down? We're about to peel back the curtain and look at the invisible engineering that powers, well, pretty much the entire digital world we all rely on every single day.
Okay, let's jump into our first big idea: how you build a digital fortress. This is all about making sure your data is safe from basically any disaster you can throw at it.
The core building block here is something called an availability zone, or AZ for short. And honestly, the best way to think about it is like a bank. Instead of keeping all your money in just one branch, your bank has multiple, completely separate branches all over town. If one of them floods or loses power, no big deal. Your money is still safe and sound, and you can just go to the next one.
So how does this actually work when you, say, save something? Well, your data doesn't just go to one place. It gets sent to a primary bank branch, which then instantly makes copies and sends them to at least two other branches. And only when all three of those locations say, "Yep, got it, it's safe," does it send back the success message to you.
And here's the part that's just mind-blowing. This whole process, writing your data to three separate, physically isolated buildings, happens in less than 10 milliseconds. That's literally faster than you can blink. It is an absolutely incredible piece of engineering that gives you safety without slowing anything down.
Okay, this is where the design really gets to show off. What happens in a worst-case scenario? What if one of those entire data centers just disappears off the map?
Let's say our main data center, AZA, completely fails. The system is constantly checking on itself, so it notices this almost instantly. And automatically it promotes one of the backup locations, AZB, to become the new primary. This whole switch happens in under 30 seconds. And for you, the user, you notice absolutely nothing. The service just keeps chugging along like nothing happened.
Now, you might be thinking, okay, that sounds great on a whiteboard, but this system isn't just theory. It's been battle-tested in the real world, under the most extreme conditions you can imagine, and it's kept a perfect track record.
You want a prime example? Let's talk about Hurricane Sandy back in 2012. Several data centers in the storm's path were knocked offline by flooding and massive power failures. But because of this multi-AZ design, DynamoDB stayed up and running with 100% availability. Users had zero downtime during a major natural disaster. It's incredible.
So as you can see, this whole fortress model is about way more than just surviving disasters. It's a smart system. It balances traffic across all the data centers to make sure things run smoothly, and it even sends your request to the data center that's physically closest to you, just to make sure you get the fastest possible response.
Okay, so we've built this incredibly resilient fortress. It's awesome, but how do you make something that powerful, affordable, and scalable enough for millions of different customers? Well, the answer is, you build a shared skyscraper.
Multi-tenancy is another one of these powerhouse ideas. Think of it like a giant, super modern apartment building. Everybody living there shares the same foundation, the same elevators, the same plumbing. It's all shared infrastructure. But, and this is the important part, each apartment is completely private and secure. You have your own key, and nobody can get into your space.
And here's a little peek at how that works under the hood. Even if customer A and customer B are running on the exact same piece of hardware, their data is kept logically separate using things like a unique tenant ID. It's literally like having different keys for different apartment doors. Total privacy is guaranteed.
Which, begs the question, if we have all this fancy tech to keep everyone's stuff separate, why even bother sharing the hardware in the first place? What's the actual benefit for you?
Well, the first and biggest reason is just simple economics. It's all about cost. In the old days, you'd have to rent out an entire server for yourself, even if you were only using a tiny fraction of it. With the multi-tenant model, you're only paying for the little slice of the skyscraper that you're actually using. It makes things dramatically cheaper for everyone.
But it is not just about cost. Imagine you're an e-commerce app and it's Black Friday. Your traffic goes through the roof. Well, you can instantly borrow all the unused capacity from the other, quieter tenants in the building. It's automatic scaling built right in. Plus, everyone gets the benefit of the landlord, in this case, AWS, handling all the security, all the maintenance, and all the cool new features for you.
Of course, the second I say the word shared, I know exactly what you're thinking. What about security? How on earth do you guarantee that one person can't peek into another person's apartment?
Well, DynamoDB builds a fortress inside the skyscraper for every single tenant. Your data is locked down with your own unique encryption key. Your network traffic travels in its own private virtual lane. And all your compute processes run in these isolated little bubbles, like secure rooms where no one else can even see what's going on. It's security at every single layer.
So now we've got our two huge ideas, the fortress for that rock-solid physical resilience and the skyscraper for incredible efficiency and scale. So let's bring them together and see the whole beautiful picture.
And this, right here, this is the secret sauce. This is the real genius of the system. It's this fusion of the two ideas. You get the physical safety of your data being copied across multiple disaster-proof buildings, combined with the amazing cost savings and scalability you get from sharing resources. It is genuinely the best of both worlds.
So that brings us to one last thought to leave you with. The next time you're streaming a movie or buying something online or even doing your banking and the app just works, there's a really good chance it's built on these exact same principles. They are the invisible, invincible foundations of our digital lives, silently making sure everything just keeps on running.